Hello students. So here we have our fifth lecture on unit 1, and in this lecture we have to study these topics: present value and perpetuity. Then we will see few questions on this topic. So before beginning the lecture, let me adjust my screen. Okay, so here I am. So we are still in unit 1, interest. So in our fourth lecture, we have seen formula for future value. We have done this topic, future value and the annuity of an annuity. The formula is this. This is the formula for future value when I have ordinary annuity, and this is annuity due. So let's start our today's topic, present value. So what is present value of an annuity? Suppose you are 57 years old and you had missed all the plans, schemes, and policies which will generate monthly income after the age of 60, or say after your retirement. Now you are worried about your livelihood after your retirement. Annuity can solve this problem. One thing is very clear, that you cannot deposit anything in annuity by installment manner because it's too late for that at the age of 57 or 58. So you must deposit in one time or lump sum amount now, then you will receive installments as salary per month in future. So again, it's a part of annuity, and we are trying to understand what do we mean by present value of annuity. So we have seen salary as a salary in future. At the age of 57, you need 35,000 rupees. So we are just assuming that every month I need 35,000 for my livelihood. Question is, how much you must deposit today in lump sum amount so that you will receive 35,000 per month. Depositing a lump sum amount means you are purchasing an annuity plan in present at the age of 57. Here, that lump sum amount is called present value. Present value is the a lump sum amount that you are depositing right now to have some income generated in future, monthly or yearly or quarterly. So formula for present value of an annuity is this. Present value denoted by PV, P upon R, 1 upon 1 plus R raised to N. So this P is the installment. So this P is the installment or salary you need in series, monthly, quarterly, or yearly in future. What is this R? This R is rate of interest, R%, and we usually divide it by 100. So this is an illustration. So my R is 0.07 if it is 7% in the question. So do not write r is equal to 7. R is 0.07 after division by 100. What is n? N is the number of installments or the salaries, number of months or number of years. So more precise thing is number of installments. So here I have a question for you. If you want proof, it's very easy to derive this formula for present value. So here's the hint for you. You can use this basic formula from compound interest amount, and this is the present principal. Use this formula, or you can search it somewhere. You will find this formula very easily. So I have skipped the proof. So finally, the present value of an annuity due is this PV. Oh no, so this is for annuity due when I want installments in the beginning. So this is the difference. So this thing is extra. So P1 plus R upon R. This bracket is as it is, the same in the immediate annuity. So the present value is this for immediate annuity. And for annuity due, this is the formula. This is all about the present value. Now let's try to solve some example. So I hope everyone is clear with the definition of present value of annuity due and the immediate annuity. Okay, so here I have a question on present value. Find the present value of an annuity of rupees 25,000 payable at the end of every month for 6 years at 9% per annum compounded. So let's read the solution. Here 25,000 is payable at the end of every month, which implies it's immediate or the ordinary annuity because in the end of every month. So the formula I'm going to use is this. So P upon R, 1 minus 1 upon 1 plus R raised to N. So what is P? P is the salary or the installment I need in future. That's 25,000 rupees every month. What is the rate of interest? Is 9% per annum. So I need to convert this rate in per annum into per month. So rate per month is 9 by 12%, and let's make it free from percentage sign by dividing it by 100. So this is the value of R. So I think that's all we need in this formula. So let's put all these required things at their places. So P is 25,000, R is 0.0075, this, and what is N? N is the number of months or the number of salaries I need for continuously 6 years. So it's like it's a monthly installment. So I need to multiply 6 by 12, it's 72. So N is 72. So what I have done here, so after dividing this, I get this. 1 plus 0.07 is 1.007, and how to take it 72th power. So it's here. So you can solve this by 1.0075. Take its 12th power first. Okay, this power 72, you can write it as 0.0075. raised to 6 raised to 12. Now it's easy for you. You can find sixth power first, and whatever may be the sixth power, take its 12th power on non-scientific calculator. Anyways, I have solved this complete bracket. It comes 0.4165. It's just a calculator job. So it comes this much. So it says that this much amount you have to deposit right now in order to receive 25,000 every month in future. 13 crore 86, sorry, 13 lakh 86,899 and 99 paisa. Next question. Find the present value of an annuity of rupees 500 payable at the end of every half year for 10 years at 10% per annum, and its compound interest. So payable at the end, so I'm going to use the present value of ordinary annuity. It is P by R. This is the formula. P is the installment amount, 500 rupees. Rate of interest is 10% per annum. And what is the rate of interest half yearly? So 10 by 2, 5% half yearly. So the value of R is, just divide that 5 by 100, 0.05. What is N? So my installment is continuing for 10 years. So in 10 years, how many half years I have? So just multiply it by 2. So number of times installment received in 10 years is 20. Let's put everything in the formula. P is 500, R is this. So take its 20th power. 20th power is this. Divide 500 by this, so it comes 10,000. And the final answer is 6,230. So this much amount you will be depositing right now if you want 500 rupees every half yearly for 10 years in future. So next question. You are making car payments of 5,000 per month for the next 2 years. Knowing that your car loan has an interest rate of 12% per annum, what is the initial price of the car? So is this question clear to everyone? So it's like installments, EMI for repayment of my car loan. And what is the amount of installment? 5,000 I am paying every month for consecutive 2 years, and the rate is 12% per annum. So let's read the solution. Treating this as an example of ordinary annuity, because normally the installments are paid in the end of month. So I'm going to take it as ordinary annuity. So this is the formula I'm going to use. P is 5,000 and it's per month. What is N? N is the number of installments I am paying. So in 2 years, 12 times, so 24 installments, and I want to repay my complete loan. So the rate of interest per month is this, 12 by 12, 1%. So what's the value of R? R is 0.01. And the remaining is routine calculation. it comes present value is 10,000, sorry, 1 lakh 6,205 rupees. So the initial or the present value of car is this. So I've taken both the cases where that installment is paid in the end of month. So it's the explanation for annuity due. So this is the difference. I need to multiply this 1 plus r to the to this value. Remaining thing is the same formula. This thing is extra. So if you do the all this calculation, you will find that the car's value is, or the cost of the car is 1 lakh 7,267. So there's a little difference in these two present values of the car. So it's 6,205, it's 7,265. So these were the questions on present value of annuity. Next topic is perpetuity. So what do we mean by perpetuity? The state or quality of lasting forever. So this is the basic dictionary meaning of perpetuity. Here I have one more definition: a bond or other security with no fixed maturity date. So this is important: no fixed maturity date or lasting forever. So let's read this definition of perpetuity. A perpetuity is a security plan that pays for an infinite amount of time or uncertain time period. So you can say that annuity with uncertain time period. If installment is paid for uncertain time of period in finite times, that is n is tending to infinity, that is the n is very large. Although perpetuity is somewhat theoretical, because can anything really last forever? Examples of it are scholarships, real estate, rent of a flat. Once you own a flat, you can rent it for indefinite time. And last example is pension. Why pension is perpetuity? I I can receive pension for the age of 90 or 100. That's finite, but it's uncertain when a person is going to die. Until he dies, the pension continues. So that's uncertain time period. That's why it comes in perpetuity. Scholarship, it's also an example of perpetuity, because the amount of scholarship, it continues for indefinite time. So here I have formula for perpetuity. Present value of perpetuity is obtained from the formula of present value of annuity. So we put n is equal to infinity in it. So here I have written n is equal to infinity. So as 1 plus r, this 1 plus r is greater than 1 raised to infinity. Any number greater than 1 and its power is very large tends to very large quantity, and its reciprocal tends to 0. So this quantity is 0. So I'm left with only this thing, p upon r into 1. That's p upon r. So the formula for perpetuity is p upon r, where p is the installment you want in future and R is the rate. So if someone wants rupees P as installment or salary every month, quarterly, half yearly, provided banks are giving interest at R% per annum, then he must deposit this much money now in lump sum amount. So perpetuity amount is P upon R. So here's the detail for P and R. So here's the question to understand the concept of perpetuity. How much money a person should deposit in a bank to ensure yearly scholarship of rupees 38,000 at at the rate of interest 16% per annum. So this 38,000 that student needs yearly. So how much money one should deposit in order to give 38,000 every year to students? Scholarships have uncertain time duration. It's an example of perpetuity. Present amount of perpetuity is P upon R. This is the formula. P amount of installment, R rate, it's 16. So bank is giving 16% rate of interest. So R is 0.16. So right now you have to deposit this much amount. So 2,37,500 if you deposit right now, then one student will receive 38,000 every year in future. So, so these are the topics I want to cover in first unit, and here we have miscellaneous examples. On the topics we have covered till now. So first question, what sum should set aside every year will amount to rupees 5 lakhs at the end of 10 years? So this is an example of annuity, assuming immediate annuity, ordinary one. Here, future amount, we want 5 lakhs after 10 years. So this is the future amount. Installment. So question is asking about how much money we should keep aside. So it's obviously this is the installment they are asking. So let that money be P or X. We need to calculate that value. N is the number of installments every year. So in this case, N is directly 10 years. Rate of interest is 12% per annum. So everything is annually. So this is the R. So just divided by 100. Formula to be used, obviously I will use future value of annuity. So this is the formula I'm using here. So future value FV is 5 lakhs. This is unknown installment. We need to calculate 1 plus R. R is 0.12 raised to 10 minus 1 upon R. 0.12. 5 lakhs. And what I have done here, so 1 plus 0.1.12 raised to 10th power, it comes 3.1584 minus 1 upon R. So after calculate this whole bracket, it comes 17.54866. You want this p, so shift this into the denominator of 5 lakhs, divide it, you will get this much, 28,492.20. So this much amount, if you are keeping aside every year for consecutive 10 years, you will collect 5 lakhs after 10 years. Next question. A man deposits 3,000 at the end of every year in a bank at the end of and at the end of 3 years he receives a sum of 10,000. Find the rate of interest per annum, and the hint is root 93 is this. So let's begin the solution. So obviously after 3 years he is receiving 10,000. So obviously this is the question of future value. So future value, this is the formula. Since it is everything is done in the end of year, so it's ordinary annuity. So this is what I have done. I have put all the values. Future value is 10,000, installment is 3,000. We need to find this R. So what I have written, let's avoid this formula to get the value of R, because the unknown R is stuck under the cube. So in order to find this R, you have to get rid of cube by taking cube root, which is not possible on non-scientific calculators. It's difficult to do that. There are tricks, but let's avoid it. So we will do it by theoretical manner. So here I have a timeline of 3 years. So this is the end of first year, end of second year, end of third year. So in the end, I'm depositing 3,000 and the rate is R%. So in compounding manner, this 3,000 rupees will grow to this amount. I hope you can recall this. This is the compound interest formula. The amount of the principal money in compounding manner. So then in the end of third year, I will deposit again 3,000, and this is the amount it grows in 1 year time span. And in the end of third year, I'm just depositing 3,000 and it grows to only 3,000. So no interest on this. So total amount in the end of third year is A1 plus A2 plus A3. And according to question, it is 10,000. So let's put the respective values. A1 is 3,000, 1 plus R upon 100 raised to 2. A2 is this and A3 is this, and everything is sum up to 10,000. Now what I have done, I have taken 3,000, 3,000, 3,000 common, and in the bracket I am left with this thing, and instead of 3,000 only 1. So this 3,000 is moving in the RHS in the denominator here. And what I have done here, since this 100 is in square, so this is 10,000. This is 100 upon 1. I have taken LCM here. So LCM will come 10,000. So I need to multiply this by 100, this by 100, by 100, this by 10,000, and this by 10,000. So LCM comes 10,000. So this thing remains as it is in the numerator. This thing I have to multiply with 100. So I have done here. And instead of 1, I have written 10,000. Now what I have done in this step, I am expanding this bracket. A plus B whole square. So 100 square is 10,000. 2AB, this is B square. I'm multiplying this 100 into the bracket, so I get 10,000 and 100 R, and this is 10,000. And what happened to this 10,000 in the denominator? I have multiplied this in the numerator. So this is here. Now let's simplify this. R square as it is. So this thing I have written 300R. So 200R plus 100R is 300R. So this is also gone. And 10,000 plus 10,000 plus 10,000 is 30,000. What happened here? So this is cancelled and I have 1 lakh upon 3. So what I'm trying to do, I'm trying to make a quadratic polynomial instead of cubic polynomial, and quadratic polynomial will be easy to solve rather than the cubic one. Now I want to simplify this. R square as it is, 300R as it is, and this 30,000 is going that side. Take the LCM into 3 upon 3. So it becomes 90,000 upon 3. So LCM is same now. So 1 lakh minus 90,000 is 10,000 upon 3. So here 10,000 upon 3, and this 3 I have multiplied to that side. So 3R square upon 300 into 3 is 900, and this 10,000 here I have shifted to that side. So minus 10,000. So here I have a quadratic polynomial. So solving this quadratic polynomial by using this standard formula, R is the value of root to this quadratic polynomial. It is given by minus b plus minus under root b square minus 4ac upon 2a. So what is this b? So this 3 is a, this 900 is b, and this minus 10,000 is c. So c is with negative sign. So let's put all the values. So b I have written 900, so it is minus 900 plus minus under root b square means 900 square, and minus 4 a. This 3 is a and c is minus 10,000 upon 2a. Now let's solve this. So minus 900 as it is here, plus minus under root 81 . So this is coming from 900 square. So it is 8,10,000. Correct? Yes. So it is the square of 900, 8,10,000. And what happened to this? From where I am getting this? 1,20,000. We had multiplied this. 4 into 3 is 12, and this negative and this negative is positive. So here I have written positive. 12 into 10,000 is this. Now minus 900 again as it is, plus minus under root. So 8,10,000 plus 1,20,000 is 9,30,000. So what I have done here, this 9,30,000, I have written 93 into 10,000. So I have separated from here. 93 into 10,000 is 9,30,000. The square root of this thing is very easy. That's why I have separated it. This is the square root of 100. 100 into 100 is 10,000. And in the question, it is given that the root of under root 93 is this. And this is the square root of 10,000. So I guess everything is done now. So minus 900 plus minus multiply this upon 6. So because of this sign, I'm going to have two values of r. R is equal to negative 900, one with positive sign 964.36, and the second one will be with negative sign. Use your calculators to get these values. So this gives me positive 10.75 and this is negative 310 point, which is not possible. Rates are normally not negative. So I am taking the rate of interest as 10.72%. So here I have one more example. A person invested 10,000 at 16% per annum, uh, rupees 8,000 at 14% per annum, and 5,000 at 10% per annum simple interest. Find the average rate of return on his investment. So this person is investing three different amounts at three different rates. And we want to find the average rate of return. So first investment is he invested 10,000 at 16% per annum. We want to find average rate. We cannot add the rates and divide it by 3. So it's not, I cannot do that. 14 plus 10 plus what? 16 and divided by 3. This is going to give me wrong average rate of return. So what we have to do, we have to find the interest gained in all these three investment patterns, and the original amount he invested. So he invested 10,000 at 16% per annum. According to simple interest, what is the interest he is going to get on this investment? 10,000 16 into 1 upon 100. So I'm keeping that for 1 year. So it comes 1600 rupees. So this is the interest on 10,000. Second investment is 8,000 at the rate of 14% per annum, and I'm keeping it for 1 year. So simple interest is this, and the third investment is 5,000 at this rate. So according to simple interest formula, the interest earned on this at this rate is 500 rupees. So total interest earned is 1600 plus 1120 plus 500. So this is the total interest earned, and how much amount he had invested. He had invested 10,000, 8,000, 5,000. So total 23,000. So on 23,000, he is earning 3,220 rupees extra. So what is the average rate of interest? So interest upon amount invested into 100, 14%. So this is the average rate of interest for 1 year. Okay, so here we have one more topic. Uh, Not a topic. This is just a relation between present value, future value, rate of interest of. I think this is for annuity. This is coming from annuity topic. This is the relation for present value of annuity, future value of annuity, and the rate of interest. What is this X? X is the installment of an annuity. Definitely, we are talking about ordinary annuity. So, this question says that the present value, okay, this is the relation between the present value, future value, and the rate. The question says that the present value and the amount means definitely a future thing, future value of an ordinary annuity is 20,000 and 30,000 respectively. If the installment is 4,500, what is the rate of interest? So present value is given 20,000, future value is given 30,000, installment X is given 4,500. Solve this to get the value of R. I think it's not difficult to do the calculations. 0, 0, cancelled here. So, and this 45, I will multiply to this side. So I get this step. 45 into 1 upon 200 minus 1 upon 300. Solve this, you will get R is equal to 0.075. Multiply this by 100 to get the rate is 7.5%. And I think this is the last question of this lecture. So let's stop here. This is the end of our 5th lecture. Thank you.